Hi all, welcome to part 19, module 2, logic system design. So we are continuing our discussion on K-map again. So hope you gone through the previous video and you're not directly coming to this, okay? Yeah, so let's see something more about K-map. Sometimes this K-map can be tricky, okay? So some scenarios explained here. So you can see that this is a situation. You don't have to worry about the labeling and all. So that is something. So we are just focusing on the grouping part only. So here, 5 ones are there, 5 minterms are there, and you are supposed to get the minimum sum of product, and how you will be making the groups. So you can have a group like this. This is the maximum I can have, right? Something like this. Fine. These two are fine. Now what about this one? This one, I need a group, right? I need a group. So I will do some overlapping and I will try to get the maximum group for this, so that I will get a minimum expression for this one, right? I want to reduce the number of literal. So what I can do is I can have a 2-element group. So this is one way for me. I can group these two ones. Now it is fine. All ones are covered and I got the expression. So that is this one, this case. That is this case. Okay. So hope it is clear. This is one way. And another possibility is like this one I can group like this also. So what is happening here? Two people will be doing two different groupings. So both are valid actually, right? So the minimum expression itself is not unique. That is what we see in here. So sometimes we will see that minimum expression, this is unique. So even as evaluators, we also have to think about it. Like so whether this possibility is also there or not. Like that we will be evaluating. Okay. So that is the thing. So two students may be writing the minimum SOP, right? So minimum sum of product for the same expression differently. So this is fine. This is also fine. Both are correct. Okay. So these terms, these groups, you write it like what is this group corresponds to and what is this group corresponds to. Okay. Let's see that also for your practice. See, labeling is missing. If you are having the labeling 0, 1, 1 0 1 1, then it is easy for you to write, right? So because that is the way we studied. So you can see that here this x is vanishing and y and z is what we can see. So it's written like this because during this window z is 1, during this window y is 1, like that. So it is just y z. Okay, that's all. So that is the way we studied. So different ways are there. So what you can see that y bar z, right? So this corresponds to 0 1, that is y bar z, and this corresponds to what? This corresponds to, again, x is vanishing and this circle corresponds to 1 0 means here two ways are there. Let me denote like this. I am just focusing on this grouping. So y z bar. So y bar z and y z bar. Y bar z and y z bar. So they are something mandatory. So whatever be the minimum expression, these two terms will be there or they are essential. So we are going to see it in detail. So we call it something as essential prime implicant. We will see what is implicant, prime implicant, and then essential prime implicant. So here I am saying it in advance. So these two terms, that is y dash z and y z dash, they are essential. In any minimum sum of product expression, these two terms will be there. So they are essential. But what about this? So if I am having a grouping like this, so suppose if I am making the grouping like this, I will get the minimum, the corresponding term, like here this x is having the form x dash, and when I am moving from here to here 0 to 1, this y is vanishing and z is there, z is 1. And if I am making this particular grouping, let me use a different color. If I am making this grouping, the corresponding term will be like x is there as it is and y is there, right, instead of z. X is x dash, fine. Sorry, it is x only, fine, because so I forgot the labeling 0 1, right? So x, it is not x dash, fine. Yeah. So these terms are like either the minimum expression may contain this one xz or it may contain xy. So here it is xy, here it is xz. So like that I am getting two different minimum sum of product expression itself for the same expression. That can happen. But so now you have to go, we are moving on to some more detail, like some of the terminologies only. So here now itself we are familiar with one terminology, that is something is essential and we call it as essential prime implicant. So we have to see what is a prime implicant, and then we will see that. So it is something that implicant, right? So the last video we discussed about the implication and how two Boolean functions can be expressed like one implies another and all. So it is somewhat similar to that. Implicants. Okay, so we are going to see what is an implicant, prime implicant, and essential prime implicant. So it's just a terminology only. Hope by this time you know how to do the minimization and all, and without knowing this terminology also you will minimize, that is for sure. But if you know it, two things are there, you will be you will not make any mistake, that is one benefit you are going to get. And another thing is like so this is a strategy, it's a systematic way. Okay, so in a unique way you will reach the correct answer. And another one is like sometimes they can ask you how many prime implicants are there in the expression, how many essential prime implicant are there in the expression. So that is one type of university question you can expect, and that time even not only for university, gate exam, everywhere such questions are coming, and that time if you don't know this term you may struggle. It's very simple thing only, so that is why we are seeing this term. Okay, so something we already seen, but we are giving them a name, that's all. So first thing is called a implicant. So what is an implicant? Implicant is a product term. So see, by default when I explain all these terms like implicant, prime implicant, essential prime implicant, everywhere I am assuming the underlying expression to be sum of product. Okay, so or I am trying to reach a minimum sum of product. Fine. So now you may ask you what about product of sum. So before also I explained you already, by default everywhere it is sum of product only. Product of sum is another standard notation which is somewhat look like a complement to this. Okay, so something like that, and that we know. Now once you know the sum of product concept, you know how to come up with the product of sum. It's very easy for you, right? So mainly in textbook and 99% of the questions, 99% of the explanation, everything is based on SOP. But and finally they will conclude like the similar way you can think about the POS also. Similarly here also, so in POS expression, instead of implicant we have a term called implicate. But anyway, in most of the standard textbook and all, you may not see this term because it's enough to understand implicant, that's all. Implicate is there, but slightly different. After understanding this you can simply correlate with that implicate. As it is not that much essential, I am not looking into product of sum, but just for your information, if you want you can link with this, that's all. Implicate, prime implicate, and essential prime implicate, like that we will call them when it comes to. So so let me write it. Minimum sum of product, we are using the term implicant, right? So the equivalent term is in product of sum minimization or the minimal product of sum expression, it is something called implicate. Okay, implicate, we are interested on implicate. This is equivalent to some term, that's all. Okay, fine. Now what is an implicant? So we will focus purely based on SOP expression. Okay, implicant is a product term, so we are focusing on that, right? So which implies F, that is the thing. So this is why I explained the last video what is that implication and all. Now you know the meaning of implication. I am not going to repeat it, just will tell you when something implies so when I can say that X implies Y, what is the meaning? Whenever X is 1, Y is also 1. Okay, if you have any doubt, please watch the previous video clearly and come to this. It will be very clear. I explained in detail what is this implies concept. And similarly, another interpretation is like whenever Y is 0, X is also 0. So that is from the basic implication definition from propositional logic we explained the last video. So please see it. But here, what is the requirement? The product term should imply the entire function. So given a Boolean function, and you know how to express the Boolean function in a K-map. So you can think of this term from the K-map point of view, also from the expression point of view. Two ways are there, whether it is implicant, prime implicant, essential prime implicant. You can visualize them with respect to the map, then it is very easy, just like some cube you have to visualize. Okay, we will see that. And also from the Boolean expression. From the Boolean expression point of view, the first definition is valid. All these are equivalent definitions for the same concept. Okay, so we will see with an example in detail. Many examples we will take, so don't worry at this point. So implicant is just a product term in a Boolean expression. You know, if the expression is in a SOP form, you know there are many product terms. So each product term that implies the entire expression. That means the product term should come from the expression. I can say that it is an implicant, right? So otherwise, this particular product term should make the function 1. So you know, as by default we are assuming sum of product, right? So a product term is making the function as 1 means this product term is part of the expression. So for sum of product, for sum to be 1, any one of the product term, it is enough for any one of the product term to be 1, right? So this is going to make the function as 1 whenever that product term is 1. So that is the basic definition, another way of saying the same thing. Now if you are looking at the K map, the same thing you can visualize like any cube of size. You know, we will group like a 2 per 0 cell, sorry, or sometimes we will group like a 2 per 2 cells, 2 per 4 cells, 2 per 8, like that we are grouping, right? So any of such cube can be called as a implicant, provided it contains only one. So all possible grouping, something like that. So the implicant is a very general term. Prime implicant is something special, we will see that. So I think just I want to give you an example for this implicant concept. Let me take the standard example from the textbook itself. Actually it is a very advanced example. I thought of starting with it so that maybe in the next video I will take very smaller and I will build the concept. But anyway, you know it, you are now ready with the advanced concept, I hope so. Here yes, I have to draw the K map. So let me show you what is this implicant and all. Say the map is containing it's a 4 variable function A, B, C, D, right? So there are 4 columns and 4 rows, fine. And let me name them. So, you know, this naming and all depends, if you are using some other material you may see in different naming convention. All are fine, provided this here we should use the gray coding, and that is our requirement. 0 0 0 1 1 0 and 1 1. Oh, everything is fine now, right? Now the terms are like this: is min term 0, min term 1, min term 2, min term 3, min term 4, min term, why should I write like this? I can just write the numbering, that is easy, right? This is min term 0, min term 1, min term 2, 3, 4. Why I am writing like this? Because if I write it, it's very easy for me to map. Otherwise, I have to use more my memory, like 0 1 0 1 0 0, what it is, like that. I don't need that mapping. That is why I am doing this. This is my way. You can do in your own way. Without writing this also, you can do this simplification. Okay, 8 9 10 11 12 13 14 and 15. See, and then I am going to map these ones over here. See, I can see that 0 is there, 1 absent, 2 is there, 3 is there, many ones are there, right? 5 is there, 7 is there, 8 is there, then 9 is there, 10 is there, 13, 15. Yeah, 13 and 15, all those things are there. So this is a map I am getting, and you know how to do the simplification, everything. So at this point I just want to take one more copy of the same. Oh, I thought like the entire thing will be replicated. No, fine. So that about it. Now see, what I am going to do is I am going to group them. Okay, so what kind of grouping I can do? So before grouping and all, here the why we taken this example, you know, the grouping, 4 element grouping, many possibilities are there for you, but why we are interested on this topic, let me just cross check one more time, something is missing, I feel. 0 is there, 0, then 2 3, okay, 4 5 7 8 9 10 11 is there, right? Most of the time I am making this mistake. 13 something I will skip, okay, fine. So that I will get a different answer. See, that's all. I hope it is okay now. Yeah, so that about it. So I just want to tell you what is an implicant, right? What is an implicant? Implicant is any product term that implies this function. So this is a function. This is a canonical representation of the function. You know, the same function you can group and you can write in a very simple form. And the requirement is, so from the K-map point of view, you can see the last definition. Any cube of ones I can call as an implicant. It can be a 1 cube, 1 element, 2 element, 4 element, 11, all are valid, right? So means if I am grouping them like this is an implicant. And as a product term, what is this implicant corresponds? It corresponds to A bar, B bar, C bar, D bar. So this is one of the implicants. So what are all the implicant? I have an implicant that is A bar, B bar, C bar, D bar. This is an implicant. Now can I make a better implicant? I mean, what I can say. So can I do some more better way. So before that, let me just tell you this. If I keep on grouping like this is another implicant, right? This is another implicant. So let me tell you what is this. This is A dash, B dash, this C and D. That is this. Similarly this one. So like that, see how many implicants are there, that is containing 4 variable. So how many such I mean single ones I can group, and I can call it as a min term. No, sorry, I can so min terms I can call it as a implicant, right? So that is what is written. Any cube of size 1 is also fine, 2 is also fine, 4 is also fine. I don't need the biggest one in general for an implicant, okay? Or product term that makes a function 1, and you know that all these products terms are making, because or any one of them is enough to be 1 to make the function 1, so all of them are making the function 1. So it is a product term that implies 1, that implies f, means whenever any one of them is 1, f is also 1, so that implication definition is also true. So all these are valid implicants. So how many such implicants are there? 3, 6, 9, 10, 11. So there are 11 terms, right? 3 plus 4 plus 11. So, okay. So there are 11 implicant, and what kind of implicant? Of 11 4 variable implicant. Let me write like that. 11 4 variable implicants are there. So that is my first observation. Now my second observation is there. Okay, let me mark them all with this dark circle, black circle. But we are not going to take them for the minimum sum of product. Minimum sum of product, we will need the largest grouping. But more min-term expression and all, we will take it. Okay, so anyway, we are just trying to say what is implicant only. So that is why. Now another grouping possible is, you can think of all 2 element groupings. So there are many 2 element grouping possible. These two ones. See, let me take a different color. If you want, you can group these 2 ones. Okay, so how many are there? It's that counting is somewhat difficult for me. So if I am grouping these 2 ones, just tell me what is the corresponding term. So one variable will be eliminated, as it's a 2 element grouping, right? This A is eliminated, right? So what remains is B dash, C dash, D dash. So that is this. This is actually something that is contained inside, or this one is something contained inside this. That is a different thing. So if I keep on writing B dash, C dash, D dash is also an implicant. And there are many. So this is on implicant. Can you tell me what is this? This is like B is vanished. A dash CD. A dash CD. Like that I can write many. I don't find it easy to count. So this one, this one, this one, this one. See, many are there. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's getting complicated. 11. Now here itself these 2, 12, valid, right? This one, 13, valid. Now these 2, 14, valid. Now what else? I think this also 15. I got some 15 grouping. Something extra may be missing. This also valid, right? 16. I got some 16. I am not sure about it. It may be something more. That anyway, I got something approximately 16 around. Okay, approximately 16 like that. Let me write. No. In all of them, 3 variables are involved. 3 variable implicants like that. So this many. Okay, I am slightly doubtful, but maybe correct. But anyway, this is a very trivial concept, implicant. Nobody is going to ask you how many implicants are there. So that is meaningless. But the next concept is important, prime implicant. We will see that. Here, just for your understanding, I am saying all these are implicants. Okay. Now I can think about what? 4 element grouping. Same figure, whether I have to make it 4 element. Okay, fine. I don't know. I can't write. I don't want to write one more thing. Okay, 4 element grouping. So after all these, there are 11 4 variable implicant, or the cubes containing 1 cell, 16 3 variable implicant, or the cubes containing 2 cells. Now we are looking at cubes containing 4 cells. So the 2 variable will be eliminated, or 2 variable implicant I will get. So there are many ways. Again, this is one possibility. See this one. Anyway, I am making the figure complicated, but hope you understand it. So if I am looking at this particular 4 element grouping, what I can see is what is happening here. This A is vanished, right? B is there, and on the top C is vanished, and D is there. Yeah, BD is one of the next category. So if I keep on writing, BD is there. So like that BD. Then here you can think of a grouping. I'm not writing all. And this is another grouping. 1, 2. This is the third one. Okay, third one. Then what else? Third one. Yeah, this is another one. Fourth one. See this particular one. Fourth one. And this is another one. Fifth one. And these corners, everything I can group together. How many are there? Sixth one, right? 1, 2, 3, 4, 5, 6, I think. I don't know. Yeah, I hope I covered all. Maybe something more. Let me write around some 6. 2 variable minterms are there. Minterms. Okay. Is there any 8 variable, 8 cell grouping possible? 8 cell grouping, or in other words, some 1 variable minterm, is it possible? Can you group some 8 cells together? If a 1 is there, I can make a grouping like this. But what I observed is like there is no 1 variable. So I written something wrong here. It's not minterm. There is no 1 variable grouping. See, there are 6 2 variable implicants are there. Implicants. There is no 1 variable implicant. Okay. So what I got is around how many implicants I got totally. So here I am getting 6 plus 16, 22, 32, 33. Right. I am getting around 33 implicants, but I am not sure about it. I am not interested on the counting also. Okay, just for your understanding of this concept. Now it is very clear, right? So all these things are implicants. I am writing it. So nobody is going to ask you how many implicants are there, or maybe a smaller question they can ask. Otherwise, there is no systematic way of counting it. Just group and say, that's all. That is why I am telling you. So you understood, right? So that many implicants I can find. Now, what makes an implicant a prime implicant? So it is something superior to all of them, something like that. That impression you are getting, right? So now we are going to see what is a prime implicant. So prime implicant, the speciality is it's an implicant which is not. See, all these are same thing with different ways of interpreting the same concept. Okay, so this is not some new point. Same thing I am interpreting in a different way for your understanding. So an implicant that is cube of ones which is not fully contained in another implicant. So the requirement is like that implicant should not be inside another implicant. Here you can see that if I am looking this BD, what is that? See this one itself, you can see that this B dash C dash D dash, it is actually coming inside A dash B dash C dash D dash, right? Okay, just wait for a second. Let me continue. Yeah, in between I drawn the same question here also, because this one if I take again it will confuse you. So let's see the same thing only. So we already seen what is an implicant. Now what is a prime implicant? Okay, so that is the question. So if you focus on some ones here, so this is one possible implicant, right? And tell me what is it? If I'm talking about implicant, so what it is? This is A dash. Corresponding to that, what I am having is A dash, B, top of it C dash and D, right? Fine. Now the same thing, I can make a bigger grouping, something like this. I can have a slightly better one, say like this. Now tell me what is this one. This one corresponds to, you can see that when I am grouping like this, A dash B will come, and when I go across the columns, the C is vanished and D will remain. But definitely I can have a grouping for the same one like this also. So I just focus on this one and I try to see what are all the grouping possible, including this one. So I just want to keep this one. This is another one. So when you focus on this one, you can see the 2 variables are getting eliminated. You can see when you go across the rows, A is eliminated and B remains. And when you go across columns, C is eliminated and D remains, right? So you can see that this is an implicant, fine. Implicant, right? This is also an implicant. This is also an implicant. Okay. Now, is it a primary implicant? No. Is this a primary implicant? No. Is this a primary implicant? Yes. That is it. So primary implicant means what? You can see that when you focus on any one, you look at all possible implicants and which is giving you the largest grouping. When it comes to the K-map point of view, the cube containing maximum number of ones. So that is a prime implicant corresponding to a particular one which I have to group. Okay, that's all. Sometimes more than one is also possible. So if you focus on this this particular one, you know, this is one grouping possible, this is another, both are prime implicant. So that is some kind of that is why you are getting more than one minimized sum of product. That is a different story, but anyway, here it is clear, right? And another way is like that should give you the smallest product term. So here comparing all of them, this BD is smallest. Or in another way, so let me give you a different definition for this prime implicant. Prime implicant, so this is more interesting. It is an implicant if we remove one variable from it, it will no longer imply f. So prime implicant of a function. So here we are talking about a function, prime implicant of a function f. Okay. So here that function is there everywhere. It is an implicant of the function. Okay. Where if I remove a particular variable from it, it is no longer imply f. Means if here you know a dash b c dash d, it is implying f. That is why I call it as an implicant. And when I remove this when I remove this c dash on variable or its complement or something, I am getting this. This is still implying this. Fine. So if I remove a variable from an implicant and what remains is implying the original function, this particular one is not a prime implicant. Because why it is not a prime implicant? Because after removing this c dash, still it is a valid implicant. That is why it is not a prime implicant. Fine. Similarly, this is not a prime implicant. Why? Because after removing this particular variable, still it is a valid implicant. See this one. That is why it is not a prime implicant. But why BD is a prime implicant? So from BD, see, very important. From BD, if I remove B, D is not an implicant. D is not an implicant, or if I remove B, D does not imply f. So if I remove B, what remains is D. Then that D is not going to imply f. That is my requirement. Also, if I remove the other one, so that is to be true for any variable. So if any one of the variable, if I remove D, what remains is B, and that B is also not going to imply f, does not imply f. So that is my requirement. I need the smallest form from where I can't remove one more variable. From the this particular form, this is one form where I can remove more variable and still I am getting a valid implicant. Here also I can remove some variable, but when I am coming to this, I can't remove any variable and still it is a valid implicant. So that is where I am getting the prime implicant. So this is the prime implicant here. So prime implicant, this is one definition, many ways you can interpret. So this is something I find it interesting. Or simply by looking at the K-map, this is the one containing maximum number of ones, so the largest grouping. So that way we will see, so because that is easy for our brain to understand, pictorially the largest cube, that's all. Or when you look at the term containing minimum number of literal, like that. So I think more definitions are also given. So it's an implicant which is not fully contained in another implicant. So here you can see that this fully not contained in the sense with respect to the cube we are saying. So this, if you are looking at this BD, it is not contained inside anyone else. But if you are looking A dash, B dash, C dash, D dash, it is actually this example, sorry. If I am looking at BD, it is not contained inside any other ones, any other cube, like that. But the other one, they are actually inside some other cube. So that is the meaning. So it is a product term obtained by combining maximum possible number of adjacent squares in the map. So this is very important. So in the cube, what you are getting, the maximum possible number of adjacent squares, that is a term corresponding to a cube of ones which is as big as possible, the largest possible one. It should be valid also. Only one should be covered, and some kind of multiple of 2, like 2 power 1, 2 power 2, that many ones should be grouped. Okay, so like that, what is a biggest you can create? It can be a product term which is as small as possible. If you are looking at it as a product term, it should be the minimum. If you are looking at it as a cube, that cube should be maximum. So it's technically called as a prime implicant. That's all. Same thing you know already. So the last definition is what I given you, a product term which implies f from which if you remove any literal. So literal is the correct term. I think I written like if I remove any variable, if I remove any one literal, because if I use the term literal, so let me erase it and write. If I use the term literal, that indicates both variable and its complement, right? So I'm happy. If I remove any one literal from that particular product term, that will no longer imply f. So that is the last definition I given. Fine. So that about the prime implicant. Now what is an essential prime implicant? If you are understanding this also, the concept is over. Okay, so that is the last thing. We will see many examples, but for the time being, I just want to explain all the terminology to you. So prime implicant is very clear too right now, right? So there are many prime implicant. Again, I will draw once again and will tell you the difference between prime and essential prime implicant. Yes, now for the last concept, to explain you what is the correct difference between prime implicant and essential prime implicant. The same example we are taking again. Now let's see, like, so tell me what are the prime implicants. So prime implicant, you should focus on the largest grouping possible, all possible largest grouping. See, this is on largest grouping. Okay, we can parallelly write the corresponding terms also. So let me tell you what is this. This corresponds to A is vanishing, so B, and this corresponds to 0, 1, C is vanishing, D. So this corresponds to BD. Now what else? Now another grouping possible is this one. Fine. Tell me what is this. Here A is there, B vanishes, then C vanishes, and D, AD. Fine. And see, here also I can have a largest grouping containing these many ones. Some redundancy may be there, but okay, just look at all the possible largest. The only criteria is like it should not contain. So it should imply that one, and it is the largest possible one that implies the F, something like that. So here you can see that when you go across a column, C and D vanishes. So what remains is A and B dash. Now similarly here, this is another grouping possible. So here also you can see that what remains, A, B vanishes, and C and D. And see, another grouping possible is these two ones after folding. That folding technique you know, right? So maybe let me use a different color. See, after folding these two ones and these two ones together, it will form what? So when you go across from first column to last column, you can see A is vanishes and B dash remains, and similarly D vanishes and C remains, B dash C. And another one possible is like the corner group, something like this one, this one, this one, and this one. All these four ones together, when you fold, will come nearby, adjacent. From first column to last column, you can see that first row to last row, A vanishes and B dash remains. And first column to last column, 0 to 1, C vanishes and D dash remains. I hope it is clear. And I hope it is correct. I may make some mistake, but still I hope you understand the way, right? 0 to 1, C vanishes and D dash remains, and here it is A vanishes and B dash remains, whatever it is. So how many such terms I am getting? 3 plus 3 plus 1, 7, right? 1, 2, 3, 1, 2, 3, 4, 5, 6. Sorry, 6 only. So which are all the prime implicants I am getting. So prime implicants, let me denote. All colors are over. So this is a prime implicant, BD is a prime implicant, CD is a prime implicant, B dash C is a prime implicant, AD is a prime implicant, B dash is a prime implicant, and this is also prime implicant. So let me write the prime implicants in this particular example are BD, CD, B dash C, then AD, AB dash, and B dash D dash. This is one way. Sorry for the inconvenience. So because if I write like that, it's more easy to visualize. So this is a prime implicant, fine. This is also a prime implicant. This is a prime implicant. So this is a prime implicant. Prime implicant. This is also a prime implicant, and this is also a prime implicant. So there are 6 prime implicants I am getting totally. Okay, keep that in mind. 6 prime implicants are there. Sometimes they can ask you this count, how many prime implicants are there. Now, the next topic, important thing. What is an essential prime implicant? Or all of them essential or not? That is a question. So, essential prime implicant means, that red color, essential prime implicant means this particular prime implicant, when you focus the prime implicant, that prime implicant should contain at least one min term or 1 in the map. Each one corresponds to a min term. At least one min term that is covered exclusively by this prime implicant. It should not be covered by a different prime implicant. If you can find out at least one such a min term, you can call it as a essential prime implicant. Definition may be confusing. Let's see. So the question is this BD, this particular prime implicant, essential? So what you have to do, you just focus on this particular prime implicant. So this is the area, right? So this is the whole thing. Maybe let me use this. This is the highlighter. So 1 second. Yes. So see, the requirement is like if you focus on this particular prime implicant BD. So let me just highlight the area. This is my prime implicant, this whole thing, right? This particular cube. Now, is there any one min term? So this is a min term. This is a min term, this is a min term, this is a min term. 4 min terms are there. Is there any one min term that is covered only by this particular prime implicant? So that is a question. So if I am looking at this particular min term, you can see that this is covered by this prime implicant as well as this prime implicant, right? This prime implicant. You can see this is part of this vertical grouping. This prime implicant CD is covering this one. Prime implicant BD is also covering this one. So because of this one, I can't call this BD as a essential prime implicant. Okay. So let me remove that. Now the next thing, I am focusing on the next one. So if I am looking at this particular one, I am just focusing on this cube only. And my question is it a essential prime implicant? Is this BD essential prime implicant? So is it essential? Because if I am looking at this one, this is being covered by, this one is being covered by this one. I mean in this, what is this? Maybe slightly I am confused. This is area. So this square, right? This square, as well as this one is covered by this square, as well as this one is covered by this square. So this one is part of some 3 grouping. So definitely it is not the reason that makes this BD essential prime implicant. So I am removing that also. Now if I focus on this particular one, you can see that this one is part of this grouping, AD grouping, this bigger cell. So this is in the overlapped region. Also this is part of this PD. So that is also not the reason. But finally, see, if I am looking at this particular one, you can see that this is exclusively covered by BD only. So it is not part of any other grouping, right? So that shaded one is making BD what? Essential prime implicants. So it's very easy concept, but you may be confused with the definition and all. So once it is clear, there is nothing to worry. So what I am saying is this is an essential prime implicant. Who made this an essential prime implicant? The min term 5. So min term 5. So that is for your understanding. Later on you don't have to think like that. Just look at the K-map and tell me which is essential or not. Due to min term 5. So for your understanding, I am writing like this. Okay. Now that about this. So what I understood is this BD is an essential prime implicant. Now my next question is this CD essential prime implicant? So another prime implicant I'm focusing, I'm look and seeing whether it is essential or not. Now you again, let me take the highlighter and tell you. If you look at the grouping, see which grouping? I mean, if you look at this grouping, so maybe just for understanding I'm taking like this. So this is a grouping I'm looking, right? This bigger grouping. Okay, if I'm looking at this particular grouping, focus on each one, say this is the first one. See, you can see that is it making this CD essential? So this is part of this grouping, as well as this one is part of this grouping also. So it is part of two groupings, so that is not going to make it essential. See, now if I am looking at this one, see, it is part of many grouping, it is part of this grouping, right? Now you can visualize from the figure itself, so that is not going to make it essential. Now if I am looking at this one, again it is part of many grouping, right? If I'm looking at this group one, this is also part of this grouping as well as this grouping. So it's getting part of two different grouping. Hope it is clear. So that is also not essential. So I'm removing it. I hope it is clear, right? So this is not essential. That is what is my conclusion. Now I am looking at B dash C dash. B dash C, is it essential? So this is this corner, this one, right? The folded one. So if you look into it, you can see that this is getting part of I'm interested on this particular grouping, and I'm going to see, is it essential? That is my question. Is it essential? See, take each one. This one, it is getting part of two grouping. You can see it now, right? You can see that this is also part of this grouping. This one is part of this grouping, as well as this one is part of this corner, three corner grouping. So that also getting part of two grouping. So that is also not a reason. Now if I am looking at this one, see, it is part of many groups, this group and this group, and this is part of this group as well as a four corner grouping, right? So nobody is making that B dash C a prime implicant. So that is also not a prime implicant. Sorry, essential prime implicant. It is prime implicant. It is not an essential prime implicant. Now what else? So like that you check one by one. So now you can check what this AD, is it? So AD, this corresponds to this one, this grouping, right? So you check, this is part of two groups. You can see that this is part of more than one group. This is part of more than one group. This is also part of not more than one group. So that AD is also not essential. So AD is not essential prime implicant. Now what remains? Now this AB dash also this one. Sorry, which is A B dash, this horizontal one. So this is this one is part of two grouping, you can see. This one is part of two grouping, you can see. This one is part of 1 2 3 grouping. This one is part of two grouping. So nobody is making this A B dash essential prime implicant. Now the last one is interesting, that is B dash D dash. B dash D dash, you can see that if you look at this one, it is part of multiple grouping. So that is not the one candidate. Now if you look at this one, it is also part of more than one grouping. That is not the one. This also not. But there is one remains. See, so that is what we are interested. Let's see. Let's give this. So the group I am interested is the corner grouping containing this one, or if you want, you can give a different color. The group I am interested is this one, and this one. Together I call it as B dash D dash, right? And my argument is this is an essential prime implicant because it contains this special one. So this is the special one I am having. So what color I can give? I don't know what color it will be. It's containing this particular one, right? This particular one, and that one is exclusively covered only by this particular prime implicant, and because of that I can say that this also an essential prime implicant. So this is also an essential prime implicant. Let me write it due to, so which min term? The min term 0, due to min term 0. Okay, so hope it is clear. I put lot of effort for you to understand. Again, we will see many example in our subsequent video so that it will be very clear. So it's somewhat a bigger example actually, but anyway, I was able to explain all the concept together. That is why I taken this. Fine. So how many essential prime implicants are there in the expression? There are two essential prime implicant, that is BD and B dash D dash. Now, what is the conclusion? The essential prime implicant is exclusively containing a one that is not covered by other prime implicant. So definitely this should be there in the minimized expression because it is already a prime implicant, means it is the largest grouping, and also it contains some min term that is not covered by others. So definitely it should be there in the final reduced expression. Okay, so that is the last point. Essential prime implicant is an essential prime implicant that includes at least one min term that is not included by any other prime implicant. Okay, hope the definition is clear. So essential prime implicant must be there in minimum sum of product expression, the minimized one. So if all the essential prime implicants together can cover all the ones, then that is enough. That minimum sum of product will be the minimized one. But sometimes it is not the case. We will see that also. Maybe let me pause and explain. Yes, now we are going to see how to find out the minimized sum of product expression. How to find out the minimal sum of product expression. So what you have to do is first to include all the essential prime implicant. So you can see that this is one essential prime implicant we saw last, right? This corner grouping. Why it is essential? Because it is containing this M0. So this is only covered by this particular prime implicant. Hope it is clear. See this one, the corner grouping as well as the middle one. Another essential prime implicant I got is this one. So, and I know that this one corresponds to what? This corner grouping corresponds to B dash D dash, right? B dash D dash, and this one corresponds to what? This one corresponds to BD. BD. And you know, in any minimal sum of product expression, these two terms are must. So what you can do is you can include them in any minimum sum of product expression. So one of the minimum sum of product expression possible is what I am writing here. It is containing this BD and also it is containing B dash D dash. Now tell me what else it will contain. So to understand what else it will contain, see how many ones are remaining. So 3 ones are remain. I just want to include them also. So add only those prime implicant. Don't add everything, which cover the remaining ones. So that is the rule. So to find out the minimum sum of product expression, first write all the essential prime implicant. That I done. Now add only those prime implicant which cover the remaining one. So that there you will get a choice. For example, if you look at this particular one, you are getting a choice like this. This is one possibility by which you can cover this one as well as this one. Okay, and another choice remains for you is this grouping. Okay, so whether you want this grouping or this grouping, that is a question. Any one is enough. As of now, let me take this grouping. Okay, so what is this grouping corresponding? This group corresponds to that one. It was CD, right? So CD is one possibility. So when I add the CD, still this one is remaining. So to include this one, again I am getting multiple choice. You know, to include this one, I can either have this group, right? This group, or I can have this horizontal group. Suppose I am going with this grouping, so that you know what is this last one. It corresponds to AD, right? A and D. I am cross verifying AD. So this is one thing. So you know CD and AD. If I add these two, you know all ones are covered, and it is a minimized expression also. Some 4 terms are there. Totally 8 literals are coming, right? Now let me write another minimized expression. So what I am going to do now is BD plus B dash D, that is there in all expression, that is for sure. Now when I write a different combination, what is interesting to me is like instead of taking this is one thing I done, right? Now the same one, you know, I can cover using this grouping also. So I am focusing on this grouping. So what is this grouping corresponds to? This group corresponds to what was it? It was B dash C, something like that. B dash and C, fine. B dash C. So what I am doing is this B dash C I am taking instead of CD. Instead of CD I am taking B dash C. See, both are having the same rule. Whether I am taking B dash C or CD, I will get cover this one and this one. Fine. Now for the last term, you know, you have one more possibility, that is this one. Let me take that. Fine. This is another possibility. So what is this? This corresponds to, I think, A B dash. So instead of this AD, I am taking A B dash. Right. Now tell me, at this point I can think of two more minimum sum of product expression. So where this BD and B dash D are fixed. Here also this BD and B dash D are fixed. Now what I am going to do is, see, here I am taking this CD, just for your understanding I am using this many colors, plus this AB dash. So these two combination I taken, they are doing the same thing, right? Now here what I am doing is, instead of CD I am taking this B dash C plus the last one I am taking it as AD. That will give me a different combination. Is this clear? In this particular example, it is happening like that. So the procedure is like, write all the essential prime implicants. So there are two essential prime implicant, BD and B dash D. So that will be there in any minimized sum of product expression. Now what remains? CD and AD. CD, AD, B dash C, A, B dash, they remains as a prime implicant. Whether I wanted to include all of them, I don't want to include. Just add those prime implicant that cover the remaining ones. So to cover the remaining one, this this CD, if I focus on that CD, that is actually covering so it is something like, let me use a highlighter. I think by this time it is clear to you. See, why I am taking this much time, if you look at the textbook and all, it is actually a difficult concept for most of you to understand, but once it is clear, it is very, very nice concept. So that is the speciality of this topic. See, this one and this one, if you focus, this one and this one, if you focus, that is something outside our essential prime implicant, right? To cover these two one, I have two choice. I can either depend on this CD, that will grouping, that CD is actually this vertical grouping, that will cover those two ones, or another choice I am having is this B dash C. So whether you want to use this CD or B dash C, so CD or B dash C, like that, two choices are there for those two ones. Right. Now if I look at so that is why I'm getting either I choose that CD or B dash C. So accordingly I am getting two different expression. Now when I look at another one, I mean what remains is actually I think this one was the next candidate. Yeah, I just want to cover this one. To cover this one alone, I have two grouping. This horizontal grouping, that is, this will cover that one. And another possibility is this AD. Both are covering. So either I can choose AD or AB dash. So accordingly, I am getting four expression, right? So that this highlighted one is having two choice. Similarly, these two highlighted ones. So let me write it like this. This highlighted one, why I am getting four choices is what I am explaining. This highlighted one is giving me two choices. So this is a very special one. This highlighted one giving two choice. Fine. And similarly I mean two choice means either use AB dash or AD, like that. Similarly, another highlighted one is this one and this one together. These two ones together is giving me two choice. That means I can either go with the CD or I can go with the CD or I can go with the B dash C. So like that I am totally getting four different minimum sum of product expression. So the conclusion is like a minimum sum of product expression is not unique. When I am giving this question to all of you, you will simplify in your own way, and four answers are actually correct. That is the thing. So they can ask you such a question also, maybe in GATE and all, so you can expect such questions. It's a very nice question. How many minimum sum of product expressions are there in the particular K-map? You can see that there are four minimum sum of product expression. It is not fine to be unique. Sometimes it is unique also. So when you are getting minimum sum of product expression as unique, it is like all the ones are covered by only the essential prime implicant. Here the difficulty what I was facing is I have only 2 essential prime implicant and they are not able to cover all the ones. So the remaining ones prime implicant I am getting a choice. So that is why they are not part of the essential, they are not essential, right? So I have 2 choice, right? So accordingly when I tried to cover the remaining ones, I got 4 different minimum sum of product expression. See, this is an example I taken from the textbook. This is how they are explaining. You can see that in the left side they are highlighting the essential prime implicant. Right side they are showing you the prime implicants, right? And that itself CD B dash C, right? These things we are also getting, right? AD A B dash A B dash, and there I am getting a choice. Accordingly, I am getting 4 different minimum sum of product expression, and in all the 4 expression this BD, B dash D. So because they are actually the essential prime implicants, so they are found to be common, and these terms are varying. Okay, so the procedure for finding the simplified expression from the map requires that we first determine all the, so that is the first thing, determine all the essential prime implicant, right? So once you determine all essential prime implicant, the simplified expression is obtained from the logical sum of all essential prime implicants. So first you take the sum of all essential prime implicant plus other prime implicant that may be needed to cover any remaining min term not covered by the essential implicant. So that is the thing. Okay. So occasionally there may be more than one way of combining the squares, and each combination may produce a simplified, equally simplified expression. That is a speciality. Anyways, hope you get an idea about it. If you have any doubt at any point, I think it is better to listen to the same video once again. It will be cleared and you can ask during our discussion session. And also the same concept we will discuss in the next video, where we will take a number of examples, right? And it will be very much clear to you. So but this is something, the foundation should be clear, then only you can go with more examples. Okay, so this video is very important. Let's keep that in mind. Yeah. Thanks for watching.